Welcome to SS2 Further Mathematics, Term 3, Week 15. Correlation measures the strength of the linear relationship between two variables. Regression finds the equation of the best fit line. Together, these tools allow us to quantify relationships and make predictions from data. By the end of this lesson, you will calculate and interpret Pearson's correlation coefficient, find the regression line equation, use the regression line for prediction, and answer WAEC Further Mathematics examination problems. Let us begin. A scatter diagram, scatter plot, displays pairs of data values, x, y, as points. The pattern of points reveals whether there is a relationship between x and y. Positive correlation: as x increases, y tends to increase, points rise from left to right. Negative correlation: as x increases, y tends to decrease, points fall from left to right. No correlation, no discernible pattern. Pearson's product moment correlation coefficient are a numerical measure of the strength and direction of the linear relationship. Formula: I equals SXY slash square root SXX times SYY, where SXX equals sigma x superscript 2, sigma x superscript 2 slash n, SYY equals sigma y superscript 2, sigma y superscript 2 slash n, SXY equals sigma xy, sigma x, sigma y slash n. Range: -1 less than or equal to r less than or equal to 1. Interpretation: I equals 1, perfect positive linear correlation, all points on a line with positive gradient. I equals -1, perfect negative linear correlation, all points on a line with negative gradient. I equals 0, no linear correlation, but there may be nonlinear relationships. R greater than 0.8, strong correlation. 0.5 R less than 0.8, moderate. R less than 0.5, weak. Important: correlation does not imply causation. Two variables may be correlated because of a third, confounding, variable. For example, ice cream sales and drowning rates are both high in summer, but ice cream does not cause drowning. Spearman's rank correlation coefficient, RS, used when data is ordinal, ranked, or when the relationship may not be linear. RS equals 1, 6 sigma d superscript 2 slash n, then superscript 2 dash 1, where d equals difference in ranks for each pair, n equals number of pairs. Linear regression finds the equation of the straight line that best fits the data, the least squares regression line, line of best fit. The regression line of y on x, y equals a plus bx, where b equals gradient, a equals y-intercept. Least squares, the line that minimizes the sum of squared vertical residuals, differences between actual y and predicted y. Formally, b equals sxy slash sxx equals forward slash a equals y, bx, where y equals sigma y slash n and x equals sigma x slash n. The regression line always passes through the point x, y, the centroid. Worked example: height x, cm, and mass y, kg, for 5 students: 160, 55, 165, 60, 170, 65, 175, 68, 180, 75. N equals 5, sigma x equals 850, sigma y equals 323, x equals 170, y equals 64.6. Sigma x superscript 2 equals 160 superscript 2 plus 165 superscript 2 plus 170 superscript 2 plus 175 superscript 2 plus 180 superscript 2 equals 25,600 plus 27,225 plus 28,900 plus 30,625 plus 32,400 is equal to 144,750. Sigma xy is equal to 160 times 55 plus 165 times 60 plus 170 times 65 plus 175 times 68 plus 180 times 75 is equal to 8,800 plus 9,900 plus 11,050 plus 11,900 plus 13,500 is equal to 5,150. SXX equals 144,750, 850 superscript 2/5 equals 144,750, 722,500 divided by 5 is equal to 144,750, 144,500 is equal to 250. SYY equals 55 superscript 2 plus 60 superscript 2 plus 65 superscript 2 plus 68 superscript 2 plus 75 superscript 2. 323 superscript 2/5 equals open parenthesis 3025 plus 3600 plus 4225 plus 4624 plus 5625 close parenthesis minus 104,329 divided by 5 is equal to 21,099. 20,865.8 is equal to 233.2. SXY equals 55,150, 850 times 323 divided by 5 is equal to 55,150, 274,550 divided by 5 is equal to 55,150, 54,910 is equal to 240. B equals 240 divided by 250 is equal to 0.96, A equals 64.6, 0.96 times 170 is equal to 64.6, 163.2 is equal to minus 98.6. Regression line, y equals minus 98.6 plus 0.96x. I equals 240/square root, 250 by 233.2, equals 240/square root 58300 equals 240 divided by 241.5 almost equals 0.994. Very strong positive correlation. Using the regression line for prediction, interpolation, within the range of data y equals minus 98.6 plus 0.96 times 172 is equal to minus 98.6 plus 165.12 is equal to 66.52 kg, for a student of height 172 centimeters. Extrapolation, outside the range of data e.g. y for x equals 200, y equals minus 98.6 plus 192 is equal to 93.4 kg. Caution, extrapolation beyond the data range is unreliable, the relationship may not hold outside the observed range. Coefficient of determination as superscript 2, as superscript 2 equals SXY, superscript 2/SXX times SYY. As superscript 2 gives the proportion of variation in y that is explained by the linear relationship with x. Example, I equals 0.994 as superscript 2 equals 0.988. 98.8% of the variation in mass is explained by the linear relationship with height. Only 1.2% is due to other factors. The two regression lines, regression of y on x, for predicting y from x y equals a plus bx, minimizes vertical residuals. Regression of x on y, for predicting x from y x equals c plus dy where d equals sxy/syy and c equals x, dy. These are different lines in general. They coincide only when a superscript 2 equals 1, perfect linear correlation. Use regression of y on x to predict y, use regression of x on y to predict x. Never use the regression of y on x to estimate x, the results will be wrong. We may wish to test whether the true population correlation coefficient ρ is 0. H, ρ equals 0, no linear correlation. H, ρ is not equal to 0, linear correlation exists. Test statistic, t equals a square root of n, 2/square root, 1, as superscript 2, which follows a t distribution with a n, 2 degrees of freedom under H. Worked example, I equals 0.6 from a sample of n equals 20 pairs. Test H, ρ equals 0 at 5% significance, two-tailed. T equals 0.6 times square root 18/square root 1 to 0.36 is equal to 0.6 times 4.243/square root 0.64 equals 2.546/0.8 is equal to 3.18, df equals 18. Critical value for two-tailed 5% test, t.258 equals 2.101. Since 3.18 greater than 2.101, reject H. Conclusion, significant evidence of linear correlation between the two variables. Spearman's rank correlation test, similar procedure using RS and a different critical value table. WAEC Further Mathematics on Correlation and Regression, calculate SXX, SYY, SXY, find R and comment on strength and direction of correlation, find regression line equation, both A and B, use the line to predict values, comment on reliability of prediction, interpolation safer than extrapolation. Common mistakes, using the wrong regression line, y on x versus x on y, calculating SXX as sigma x superscript 2, instead of sigma x superscript 2, sigma x superscript 2/n, confusing R with a superscript 2. Key points: scatter diagram reveals direction and strength of relationship. Pearson's R, I equals SXY/square root, SXX times SYY, minus 1 less than or equal to R less than or equal to 1. SXX equals sigma x superscript 2, sigma x superscript 2/n, SYY equals sigma y superscript 2, sigma y superscript 2/n, SXY equals sigma xy, sigma x, sigma y/n. Regression line y on x, y equals a plus bx, b equals SXY/SXX, a equals y, bx, passes through x, y. A superscript 2 equals coefficient of determination equals proportion of variation in y explained by x. Two regression lines, y on x and x on y, use appropriate line for appropriate prediction. Hypothesis test for rho equals 0, t equals a square root n 2 / square root 1 a superscript 2, df equals n2. Spearman's rank correlation, RS equals 1, 6 sigma d superscript 2 / used for rank/ordinal data. Correlation is not equal to causation. WAEC test, compute R, find and draw regression line, use for prediction, interpret R and a superscript 2, discuss validity of extrapolation.